Welcome to Học Tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, a history of science in 100 experiments. Today, we are going to read story, let's see, number 61, Journey to the Center of the Earth. Experiments are not always triggered by people, but scientists can still make good use of them by careful observation and analysis. The discovery of the Earth's core is a classic example. Emil Wiechert, a German geophysicist, realized in the middle of the 1890s that the interior of the Earth must contain a core much more dense than the surface layers. Thanks to the Cavendish experiment, he knew the mass and overall density of the whole Earth, and it is straightforward to measure the density of rocks at the surface. He worked out a detailed model for the inner structure of the Earth to fit the observations, and presented an early version in a lecture in Königsberg in 1896, followed the next year by a full description. He estimated that the Earth has an iron core with a radius of 0.779 times the radius of the Earth and a density of 8.2 grams per cubic centimeter, while the outer layer, the mantle, has a density of only 3.2 grams per cubic centimeter. These are not hopelessly different from modern measurements. Wiechert realized that this idea could be tested by studying earthquake waves, which travel from their point of origin through the interior of the Earth and can be detected on the other side of the planet. This was the necessary natural experiment to test his theoretical model. Coincidentally, in 1897, the same year that Wiechert presented his detailed model, a major earthquake in India set the British geologist Richard Oldham on the path to making that test. Oldham was born in India, where his father was a geologist studying earthquakes. In his turn, he joined the Geological Survey of India and made a major study of the magnitude 8.1 Assam earthquake in 1897, which was felt over an area of 250,000 square miles. From this work, he discovered that there are three different kinds of seismic waves that travel at different speeds. P waves, the P stand for either primary or pressure, travel the deep earth and are the first to arrive at a distant seismograph. They are push-pull waves like sound waves in air. The second waves to arrive at the seismograph are known as S waves. The S stands for secondary or shear, which also move through the deep earth, but with a wave motion at right angles to the direction of wave movement, like ripples on a pond. There are also surface waves, which travel along the surface of the earth with devastating but local effects. Oldham left India in 1903 to settle in Britain, where he used his new insight to analyze seismic data from around the world for thousands of earthquakes, thousands of natural experiments. He studied the way waves are refracted and change speeds as they pass through the interior of the Earth, and found that earthquake waves initially increase in speed as they move into the Earth, but that at a certain depth they suddenly slow down. This showed that the wave had reached the boundary of the core. His results were published in 1906, the year of the Great San Francisco earthquake. Oldham was awarded the Lyell Medal of the Geological Society of London in 1908. Wishart, who had seen iron meteorites, had suggested that the Earth might be like a giant meteorite with a core of nickel-iron metal that had settled to the center. Oldham's measurements of the change in speed of earthquake waves within the Earth implied that the core must actually be liquid. It was only in 1936 that the Dane Inge Lerman discovered that there is a small, solid inner core which reflects seismic waves. Modern measurements place the top of the outer core at a depth of 1,796 miles, 2,890 kilometers below the Earth's surface, while the inner core begins at the depth of 3,200 miles, or 5,150 kilometers. The radius of the Earth is 3,952 miles, or 6,360 kilometers. Because volume is the cube of the radius, this means that the whole core occupies 16% of the volume of the Earth, and the inner core just under 1% of the volume. The core has roughly half the radius of the Earth, and therefore roughly 1/8 of the volume, because 2 cubed is 8. The densities range from 9.9 to 12.2 grams per cubic centimeter in the outer core, and slightly higher, perhaps 13 grams per cubic centimeter in the inner core. The inner core may be crystalline, although it's very hard to test this idea. Swirling fluid currents in the outer core are probably responsible for generating the Earth's magnetic field. To the vocabulary section. Trigger, trigger. Geophysicist, geophysicist. Interior, exterior. Core, core. Dense, dense. Straightforward, straightforward. Mantle, the earth mantle. Earthquake, earthquake. Coincidentally, coincidentally, coincidentally. Magnitude, magnitude. Seismic, seismograph. Seismic, seismograph. Ripples on a pond. Ripples on a pond. Ripples on a pond. Devastating, devastate, devastating. Insight, insight, insight. Refracted, refract. Meteorites, meteorites. Depth, depth. Crystalline, crystalline. Maybe crystalline, I'm not too sure. We have to check. Thank you very much for your time, and as usual, I will see you in the next video. Bye for now.